So before we get into too much of what's expected of you in this first phase, we need to discuss some terminology. There's one very important piece of information that you need to understand, and that's the idea of a programming objective. Part of your task for this first phase is to choose 5 of these or come up with any one of your own on top of these. Basically, a programming objective is one significant and fundamental programming goal of the project. So think about the game Angry Birds, and some programming objectives in the game Angry Birds might be like projectile motion or collision detection. Now think of Angry Birds without the ability to collide. That means the birds you throw wouldn't hit any of the blocks wouldn't hit each other. It'd be a pretty useless game. It would defeat the whole purpose of the game. But that objective, that idea of collision detection, is significant not just in its necessity in the game, but it's significant in its complexity in its implementation, so how you actually do it. In that game, there's a lot more than just box-to-box collision going on. There's circle-to-box, there's all these different awkward shapes that are not really the same or very simplified. So what I've done here, as you can see on the screen, is I've come up with 12 common objectives, programming objectives that I've seen over the years on behalf of the students. Now these objectives, depending on how far you go with them, can be more complex or simplified based on what you choose to do with it. So I'm going to do a quick little discussion about each one just to try and give you an overview, and your job for this first phase is to choose 5 of these that's going to be in your game, or come up with some of your own on top of this. Now remember, if you're coming up with some on your own, they need to be significant enough and challenging enough relative to your skill level to be counted as a valid objective. So you may be denied in whatever you choose to do. So the first one we're going to look at is one called resource management system. Now a resource management system, or an economy, is something that we see in a lot of games like real-time strategy games like Command and Conquer and stuff like that, but we also see it in games like Tower Defense. So imagine a game where you have to collect certain resources. So you might see something, let me just get my pen going here. Let's go over here, let's change our color to black. So you might have a game where you might have to cut down a tree, right? Or you might have to harvest some wheat, right? Just to get different things. So this might be wood, this might be grain, and then you might have a little sheep over here, and this sheep might produce wool. Now these 3 resources may be something that you can collect and then use to build and or purchase other things in the game. So if you're thinking like the classic game of Settlers, for example, a classic board game, you require these 3 plus some brick to build a house. If you want to, now let's back off for a second. Let's talk about other games. Maybe you're building a tower defense game, and a tower defense game requires you to have both towers and troops and everything like that. Maybe your troops require grain in order to feed them, right? So as you go through the course of your game, your idea is to manage these resources. What that means is not only do you have to collect them, but there must be some form of limitation on them. Maybe you can only collect so many at a time. Maybe some are different values. So maybe wool is more rare than grain, something like that. Anything that has the word management in it means that the user needs to be making choices. Needs to make tough decisions while they play their game. What that means is basically when their users confronted with different options to build different things, they may choose option A versus option B because they may want to conserve some of their resources for later bigger purchase or something along those lines. So resource management system is something like this. What a resource management system is not is just collecting a series of coins. For example, in the original Super Mario Brothers, you collect 100 coins, it automatically purchases a free life for you. There's no choice involved in the player there. In fact, that is too easy of a system. Really all you're doing is increasing or decreasing an integer. Not very effective and not very challenging. So we'll get into some more on the